First time right. How do we get AI to deliver the right results the first time? That was the quest I embarked on. I needed to combat the uncertainties that surround all the AI systems that we have today. And I also have to strive for convenience, for speed, so that I can focus on delivery rather than operations and enablement. And I succeeded. I came up with the revolutionary feature document. Well, it's not revolutionary, but it did make a big difference in terms of how predictable the results became. So let's have a look. This is the story of No Pressure, the AI native, tiny little website system. This is going to be a two-part video. This is part one, focusing on what the feature document is and why it works. And then there will be a second video, a playthrough, where I take a specific new capability, feature in No Pressure from the beginning and show how it works in real life. So please like and subscribe so that you get notified when the video gets posted. Okay, so let's get back to our quest. The first question is, wouldn't just prompting the LLM do the job? Well, if the system is really tiny or the change is really small, maybe. But there is one big problem with this, which is that the LLM will assume a lot of things. It will be opaque what it wants to do before it does it. So then you have to review the work itself it produced and figure out whether it is fit for purpose or not. This may work on a really tiny system, but if you want maintainable code and repeatable processes, prompts will just not cut it. We need a clean way to document our objectives, track our status, and keep the requirements and the documentation. And requirements in this case really refer to the future state, and the documentation refers to the current or past state. So how do we manage all this? The first question is, where should we keep them? Should we have a specialized system that is outside the code repository, or do we want to store them in the repository? Thinking about documentation in the first place, that fits into the code repository pretty well. So I would just say, keep it in the repository. But if we take requirements, status, objectives, there are really good systems that work really well for this purpose, like Jira. It's very good at storing requirements, tracking status, and reporting on it. Now here your mileage may vary, because if you have an operations team, and bless them, they work so hard to keep all the systems alive, if you have their support, then by all means use Jira. But if I have to maintain a system and the integration and keep in sync the repository and the tracking system, it's just a lot of overhead. So from my perspective, keeping everything in the repository is the better choice. But this also means that we need to use some sort of document that can be stored in the repository with ease. Now the next question is, why on earth would we want yet another document format? There are indeed a lot of different document formats, and I tried them. Well, maybe not all of them, but I tried a few, and none of them really worked out well. Let's have a look at a few of them. Take, for example, the PRD, the Product Requirement Document or Project Requirement Document, which seems to be widely used for AI projects. I tried it, and it worked to a certain extent. Where it fell down for me was the first objective, combating uncertainty, and particularly around managing the context window. I used the PRD to launch a new mid-size project, and it started out quite well. But over time, it became ever more difficult to keep the AI on track, as the whole project scope is in the document and therefore it's read by the AI. It became ever more difficult for the AI to differentiate between what was already done and what was still needed to be done. I concluded that I needed a document format that was much more limited in scope, much more focused on the specific area I was working on. Even for a greenfield project, breaking it up into smaller pieces was more efficient than having one big PRD. In the same spirit, the BRD, the business requirement document, and the FRD, the functional requirement document, the pair, which are the two initial documents for the waterfall model, have the same issue. In fact, they are probably even more complex than a PRD. So those would not be fit for purpose either. Now, what's the story with user stories? To begin with, those are more at the business requirement level. Although there is one system, Kiro, the AWS IDE, which uses the user story format even to describe the functional and technical requirements. I tried that too, and I have to say it was really difficult to interpret the requirements that way, and it was too complicated to use for me. Your mileage may vary. So, I just excluded all the usual documentation formats. What gives? What should I use then? You see, we face this kind of triangle, where we have on the one hand the documentation, which represents the past. We have the requirements, which represent the future state. And then in between, we have the code base, which is representing itself, which is the present. How can we harmonize all this and manage the status in a way that is simple for me and simple for the LLM? How can we bring these together? Well, I just quite literally brought them together. In the feature document, the idea is that we keep together the current state and the future state, and we manage the scope so that it's small enough for me to understand easily and also for the LLM to focus on it and implement it, ideally in a single pass. How do feature documents work then? First is the scope. The length should be no more than what I can read in 5 to 6 minutes. The second is the structure. It has a header which has the objectives and the status in it. Then it has the action plan. This is for the documents where we are describing a change. And third, we have the technical details. The technical details section includes both the documentation of the current or past state and the future state. And it seems that if both are in one document and clearly marked, this helps the LLM distinguish between the two and not get confused when the codebase is in a third intermediate state, still being processed, not even after compacting the context window. So that's the format. And the beauty of the feature document is that it's evergreen, because once the change is implemented, the new feature is developed, or the change on an existing feature is done, then it becomes just the documentation, reflecting now the future state, which has become the present. This is supported by a simple process. I start out by asking the AI to either create a new feature document or update an existing one, marking it as updates required. I give it the objectives and ask it to write the document. Now, this is unlikely to be perfect, so then we get into the iterative phase, where I ask the AI to make the necessary modifications. And it's very important, this is really critical, because this is where the assumptions come out that the LLM would make unless we bring it out and explicitly document it. What is important to cover here are the data structures, the data flow, how does it get from one part of the system to the other, the protocols, and going down into the how, not just what we want to implement, but how we want to implement it as well. And not to forget, tests. We have to make sure that there is clarity around what kind of tests we want How do we want to structure the action plan so that we get testing as soon as possible and thereby give feedback to the AI as soon as possible so that the code quality will be high from the beginning? And here it is extremely important to keep the scope small and really something that can be read in 5-6 minutes and easy to understand. If it becomes too big, then I just ask the AI to split it into meaningful smaller pieces so that I can ensure that I really understand what's going to happen. Once I'm satisfied what's in the document, I can have the AI execute the action plan. So 2 important notes here. One is that this is a 2-part video. This is the theory part. There will be another, a playthrough, where I actually use this format and process to go through step by step the development of a new feature in no pressure. So please like and subscribe so you get the notification when it gets posted. The other note is that in the show notes, there is a link to download the instructions I give to my agents how to construct the feature documents. So have a look, download it, and if you use it, please do share your experience. Comment and let me know how it worked for you. Okay, so that's the feature document. What do we get out of it? One side effect is that each feature document naturally becomes the single source of truth for a specific element, feature, component. The reason is that we keep both the requirements and the current state documented in one place. The LLM doesn't need to read other documents to get a full picture about the specific area. And even if more than one feature document needs to be read, each of them have a pretty defined scope. So that reduces the risk of confusion. So let's go back to our quest and our objectives. Our first objective was to combat the uncertainties. Let's look at them one by one. Can we mitigate model change? Well, unfortunately, probably not. If the model becomes dumb, then no document will help. This is what happened with ChatGPT 5.1. The options I had were to stick with 5 or just wait for 5.2. There was just no way to mitigate how the LLM behaved at the documentation level. Now, what about system prompts? It's very hard to detect system prompt changes, unless they are so extreme as I had with Gemini 2.5 that I described in an earlier video. So I can't be sure, but using consistently the same model over time, I did not see any variations in the quality or predictability of the delivery so far. I think that a simple documentation format and a simple process may mitigate minor changes to the system prompts as well. And now we come to the context window. By keeping the scope limited, we are already mitigating the pollution of the context window. We don't get the LLM to read the full scope of the project. We significantly limited what it needs to read to get on with the work. So that's one side. The other is poisoning. This means when the context window is compacted and the LLM loses a lot of context, it will reread this single document which contains both the starting point and the end point and also the trajectory. And that appears to completely mitigate the poisoning risk. So that's the quest completed. Please have a look at the show notes for more details. And watch out for the second part, the full playthrough from start to finish to develop a new feature for no pressure. Because no pressure it is. I'm TeeAy. Thanks for watching and see you on the next video.
Please like and subscribe. It helps us bring you more great content. Thanks for watching.